Hello and welcome back to the next mathematical symbol, which is given by these pointy brackets. Often there is a comma in between, but sometimes you also see a straight line. And this is, in mathematics, how we denote an inner product. This means it's a special multiplication we find in a vector space. So you see, one vector you would put here on the left hand side and another one here on the right hand side. Hence, if we call the vector space V, we can see it as a map defined on the Cartesian product V with itself. And then the outcome of this inner product calculation should be a real or complex number. Hence, we immediately recognize it's a very abstract concept, but it has a lot of concrete applications. For example, it's used a lot in physics, and especially this notation you will see in quantum mechanics. As an example, we can say in quantum mechanics they would calculate the inner product of two states, psi and psi tilde. And then they might say this is the bracket notation of quantum mechanics, but mathematically it's just an inner product in a vector space. However, then in physics you also see a funny thing, they separate this bracket. On the one hand, they say we have a so-called bra vector psi, and on the other hand a so-called ket vector psi tilde. And then you can argue putting both things together gives us a so-called bra ket. In short, you can just say this is another way to explain the inner product. In physics, this is usually called the so-called Dirac notation. And if you want to learn more about this and inner products, I have a whole functional analysis course you can watch. So I really hope that I see you there or in the next video about mathematical symbols.